Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. It is 3.5, Finding Real Roots of Polynomial Equations, Day 1. The first thing we're going to talk about is multiplicity. Multiplicity of a root is the number of times it is a factor of the polynomial. Graphically, this is when the graph will touch the x-axis but does not cross the x-axis. That would be even multiplicity, or it bends at the x-axis. That is odd multiplicity. When it says it does not cross the x-axis, that's when the same x-intercept would have a multiplicity more than one time. Okay. So the first thing we're going to look at is x squared plus 4x minus 12. When we're looking at x squared plus 4x minus 12, we need to go ahead and factor that. So we need to figure out the multiples of 12 that could possibly add to 4. So I have 1 times 12, I could have 2 times 6, I could have 3 times 4. Will 1 and 12 ever get me to positive 4? No, it won't. Will 3 and 4 ever add up to positive 4? No, it will not. Now remember, if it is a negative in the back and a positive in the front, it's going to be positive and negative. Okay? My first blank is always x. My second blank, we need to find what could add to positive 4. So I have 6 and 2 up here. So it would be a positive 6 and a negative 2. From here, what I need to do is I need to set those both equal to 0 to find out my x-intercepts. So x plus 6 equals 0. If I subtract 6 from both sides, x would equal negative 6. X minus 2 equals 0. If I add 2 to both sides, then x would equal positive 2. So this is going to cross at positive 2 and negative 6. So it would cross somewhere in there. It's going to bounce down here somewhere. My graph would look something similar to that. So in this case, the graph only touched negative 6 once, so I'd have a multiplicity of 1. It only touched x equals 2 once, so I have a multiplicity of 1 for that as well. All right. Now, on to the next problem. The next problem says that I have x squared minus 4x plus 4. Remember, if there's a positive in the back, then I would follow the sign in the front, so they're both going to be negative. My first blank will be x. What are my multiples of 4 that could possibly add to negative 4? 1 times 4. 2 times 2. 1 and 4 would never add to 4, but 2 and 2 will, so I can put 2 here, 2 here. Now I need to set this equal to 0, so I could have x minus 2 squared is a way I could rewrite that, is equal to 0. In order to solve for x, I would need to take the square root first. X minus 2 still equals 0. Add 2, so x would equal positive 2. Here's the thing about that, though, is because my graph has the same answer twice, x minus 2 twice, it's going to actually bounce off of positive 2. So this is when we say that it has a multiplicity of 2. Another way to know that is I have squared here. I had to take the square root. Whenever I have to take the square root, it's going to have a multiplicity of 2. All right? Or not whenever I take a square root, I'm sorry. If I have 2 of the same answers, don't necessarily erase this, but if you see right here, I had x minus 2 and x minus 2. Since I could set these both equal to 0, this would get me positive 2. This would also get me positive 2. So as you can see there, my 2 answers are both positive 2. The other way that we went about it, we ended with x equals 2. So that's where we would say we have a multiplicity of 2. All right, on to y equals x minus 3 cubed. Do not write this, but just pay attention. I could rewrite that as x minus 3 times x minus 3 times x minus 3 is all equal to 0. I could set each one equal to 0 if I really wanted to, but that would take an extra lot of time, or a whole heck of a lot more time. And also, it's going to take a lot more room. So what I'm going to do instead is take x minus 3 cubed, set that equal to 0. I'm going to take the cube root of x minus 3 and 0, so I'd have x minus 3 is still equal to 0. Add 3, So x equals 3. But since I actually had x minus 3 times in this problem, my multiplicity here is going to be 3. The other thing that we have to know about is a cube root graph is one that kind of looks like that sideways S is going to go through x equals 3. And notice, based off of what the explanation of multiplicity was, if it goes through, it bends at the x-axis, then we're going to have an odd multiplicity. Well, the number 3 is odd. What you're going to notice from the problem right before, when I had a multiplicity of 2 or an even multiplicity, is my graph went ahead and bounced off of my x-axis. Okay? You're not going to have to worry about graphing these on this worksheet, but you will have to know how to factor and solve each one of these. Remember, all the things that I just talked about as far as factoring, we have gone over before. So if you're still struggling with that, make sure you come in and get some help. All right? Now, we need to solve each polynomial equation by factoring. Then we need to state the multiplicity of each root. Okay? So the first one here. This has 4 terms. Recently, we've been talking about something that when I have 4 terms, I can factor in a certain way. What did we say that was? Well, that was factoring by grouping. To group, I go ahead and make a line right down the center. I'm going to find the GCF of these two. Well, 6 and 2 are both divisible by 2. They both share an x squared. So the GCF of my first group is 2x squared. From there, remember, I want to make a set of parentheses. Well, 6 divided by 2 would be 3. X cubed divided by x squared would be x. 2 divided by 2 would be positive 1. X squared divided by x squared would just be I took both the x squareds away, so I would not have any x's left. All right. In my second group, I also have a GCF. What I'm trying to find is this 3x plus 1. I want what's left over from this group to be 3x plus 1. So since that's the case, what I did to figure this out is I took negative 54 and divided it by 3 to see if I could find a GCF. When I did that, I found out that they were both divisible by negative 18. The reason why I want negative 18 is I want my x to be positive. So negative 18 is the next thing I'm going to write. Inside the parentheses, I end up with 3x plus 1. Now, the next step to solving by grouping is to write my GCFs in a parenthesis on their own, and to write the 2 identical parentheses in one set of parentheses on their own. From here, I'm going to solve this first. I'm going to check this first set of parentheses to see if there's anything else I can do as far as factoring goes. Well, the first rule of factoring is a GCF. They're both divisible by 2. That would leave me with x squared minus 9. Then I can check the next set of parentheses, this 3x plus 1. Is there anything else I can do with that to factor? There is not. So it'll be 3x plus 1. All that's still equal to 0. Now I want to check this set of parentheses to make sure there's nothing else I can do. Well, x squared is a perfect square. 9 is a perfect square, so I have the difference of 2 squareds. Remember, I'm going to make 2 sets of parentheses in that case. X would go in the first blank, positive, negative. The square root of 9 is 3. I have not changed my second set of parentheses from above. So now, looking at each set of parentheses, there's nothing more I can do to factor. So what I'm going to do is set everything equal to 0. So 2 would equal 0. X plus 3 would equal 0. X minus 3 would equal 0. And 3x plus 1 would equal 0. What I want to draw your attention to real quick is this set of parentheses. There's no other x plus 3, there's no other x minus 3, and there's no other 3x plus 1. So right now, what you can think is that I have a multiplicity of 1 on every single answer. Okay? I'm going to subtract 3, so x would equal negative 3. I'm going to add 3, so x would equal positive 3. I'm going to subtract 1, so 3x is equal to negative 1, divided by 3, x would equal negative 1 over 3. Okay, you should be able to do that as well. Is 2 equal to 0 right here? Is 2 equal to 0? No, it's not, so that's just going to go away. Again, what is my multiplicity? There's only one answer of negative 3 in this problem, so that's a multiplicity of 1. There's only one x equaling positive 3, so multiplicity of 1, and only one x equals negative 1/3, so a multiplicity of 1. Okay? On to problem number 2. In problem number 2, I have 3 terms equal to 75. We haven't really done anything where I would have 3 terms equal to a number, so what I'm going to do is set it equal to 0, which is what we've talked about numerous times, is the first thing that we would want to do when factoring. When I set it equal to 0, I now have 4 terms. What do I do when I have 4 terms? Put a line right down the middle because I'm going to factor by grouping. I'm going to subtract or get rid of this minus 75s here. They're going to get in our way. So now I'm going to take my first group and find the GCF. There's no number out front, so it won't be a number, but they do both have an x squared. So I'd have x squared. What's left from the group? Well, x to the third divided by x squared would leave me with just x. Negative 3x squared divided by x squared would leave me with negative 3. Then I'm going to check for a GCF in my second group. They're both divisible by 25. So positive 25 will be written next. Well, 25x divided by 25 would just get me x. Negative 75 divided by 25 would get me negative 3. Okay. Now I go ahead and I'm going to write my 2 GCFs in a set of parentheses together. Then I'm going to write my identical parentheses in a set of parentheses. And we are done with factoring by grouping. What I need to look for next is, will either one of my sets of parentheses factor further? Well, x squared plus 25. I do have x squared, which is a perfect square. I do have 25, which is also a perfect square. The problem here is it's not the difference of 2 squares, it's the sum of 2 squares, and we have never done anything with the sum of 2 squares where I can actually continue. X minus 3, there's nothing more I can do there. So what we would do now is we would go ahead and set them each equal to 0. So I'd have x squared plus 25 is equal to 0. X minus 3 is equal to 0. Well, x minus 3 is pretty easy. I'm going to add 3 to both sides, so x would equal 3. Note, there's only been one x minus 3 set of parentheses in the entire problem. So this is a multiplicity of 1. For x squared minus 25, I need to get x alone, so I'll subtract 25 first. So x squared is equal to negative 25. Square root, so x would equal, what is the square root of 25? Well, the square root of 25 would be plus or minus 5. Remember when we did square roots before, though, if it's a negative, there's always going to be an I included. What I can see here now, though, is x would equal positive 5i, x would equal negative 5i, because I'm afraid that if we keep it written as x equals plus or minus 5i, you're going to tell me it's a multiplicity of 2, when really each one is only a multiplicity of 1. Okay? Moving on, down to number 3. I have 4x to the 6th plus 4x to the 5th equals 24x to the 4th. Again, I'm going to start this off by setting it equal to 0. So I'm going to have 4x to the 6th plus 4x to the 5th minus 24x to the 4th because I had to subtract that in order to set it equal to 0. Here, I only have 3 terms, so I cannot factor by grouping. I'm just going to do normal factoring. The first rule of factoring is always a GCF. Well, 4, 4, and 24 are all divisible by 4. So if I take out a 4, I want to look for any x's that they share. Well, this group has 6 x's, this group has 5 x's, this group has 4 x's, so each one of my terms actually has 4 x's, so that would also be in my GCF. That would leave me with 4 divided by 4 is 1. X to the 6th divided by x to the 4th would be x squared. 4 divided by 4 would be 1. X to the 5th divided by x to the 4th would leave me with a single x. Negative 24 divided by 4 would be negative 6. X to the 4th divided by x to the 4th is not going to leave me with any x's left. Okay? Now what's the next step? I need to see if I can factor further. Well, 4x to the 4th, there's nothing more I can factor there, so that's just going to go ahead and come down. X squared plus x minus 6. Let's check our factors of 6 to see if any of them could add to positive 1. Well, I have 1 times 6 and I have 2 times 3. 1 and 6, no matter any combination of 1 and 6, will never get me back to 1. But 2 and 3 could. Since 2 and 3 will, I'm going to go ahead and set up my 2 sets of parentheses. My sign in the back is negative, which means that my sign will be positive and negative. X squared breaks into x and x. I need it to be a positive 1, so my larger number needs to get the positive sign. And we are done there. Again, I want to double check that nothing else can be factored. Well, again, 4x to the 4th cannot be factored any further. X plus 3, there's no x squared. So I don't have a difference of 2 squares. I only have 2 terms. So that can't be factored any further. X minus 2, same deal. That cannot be factored any further. So at this point, I know that I can just set everything equal to 0. So 4x to the 4th would be equal to 0. X plus 3 would be equal to 0. X minus 2 would be equal to 0. I'm going to solve this first one first. 4x to the 4th. I need to get x by itself, so the first step would be to divide by 4. That would leave me with x to the 4th is equal to 0. All right. So really what that means, do not write this down, just pay attention. What this really means is I have x times x times x times x is equal to 0, which means I could write x equals 0, x equals 0, x equals 0, x equals 0, right? Well, since I could do that, that means I have a multiplicity of more than 1 because I have 0 as an answer multiple times. I just wanted you to understand why my multiplicity is going to be what it is here in 1 second. In order to solve for x, I would take the 4th root. So x would equal 0. And just like because of the explanation I just gave you, my multiplicity would be 4. Okay? To solve x plus 3 equals 0, subtract 3 from both sides. X would equal negative 3. My multiplicity would be 1. Add 2. So my multiplicity would be 1 again. All right? So if you have not figured this out yet, multiplicity means how many times is that an answer for our problem. Well, 0 could be an answer for our problem 4 times. Negative 3 could be an answer for our problem once. 2 could be an answer for our problem once. All right? On to problem number 4. I have 4 terms. I'm set equal to 0. The first thing I could do here is pull out a GCF. But because I have 4 terms, I'm going to try to group first. Well, 3x to the 5th and x to the 4th, they share 4 x's. So my GCF is x to the 4th. That leaves me with 3x plus 1. Negative 27x to the 3rd and negative 9x squared will share a negative 9x squared. So negative 9x squared comes out. I would have positive 3x plus 1. All right. Now, just like the rest of the groupings we have done, x to the 4th minus 9x squared goes into a set of parentheses by itself. The matching parentheses turn into one set of parentheses. Now I need to check to see if anything else can be factored. Well, I have x to the 4th minus 9x squared. That does have a GCF of x squared. That would leave me with x squared minus 9. The 3x plus 1, there's nothing more I can do with that, so I'm just going to leave that as 3x plus 1. Now, is there anything else I can do with x squared? There is not. However, x squared minus 9. X squared is a perfect square. I have a subtraction sign. 9 is a perfect square. So it's going to be 2 sets of parentheses. a positive sign, a negative sign. X goes in the front. Square root of 9 is 3. Don't forget about your 3x plus 1. All right. Now, is there anything else I can do to factor any of those four different parts? There is not. So what I'm going to do from here is set everything equal to 0. Another way you can find a multiplicity or know that my multiplicity is going to be higher than 1 is when it is set equal to 0, like this right here. If I have a squared, like x squared, or don't write this down, if I had something like x minus 3 squared is equal to 0, either one of those, then my multiplicity is going to be higher than 1. Because that is saying that x equaling 0 could be an answer more than one time. To solve this, I'm going to go ahead and square root it. So x would equal 0. My multiplicity would be 2. Subtract 3. So x equals negative 3. My multiplicity is 1. Add 3. My multiplicity is 1. Subtract 1. Divide by 3. X equals negative 1 over 3. And that multiplicity is 1. Okay? Let's go ahead and move to the back. Keep it moving here. Keep it rolling. All right. On the back, I have 3 terms. So that means I will not use grouping to solve this. So I'm going to look for a GCF. Well, I don't have a number in front. I do not have an x behind, which means that I will not have a GCF. But 36 could possibly add me to negative 13. I have 1 times 36. I'd have 2 times 18. I'd have 6 times 6. And I would have, whoops, I skipped one there. I skipped a couple, actually, I'm sorry. I would have 3 times 12. Could have 4 times 9 and 6 times 6. Okay? Would 1 and 36, any combination of that, ever add to negative 13? No, it will not. So that's not going to work. 2 and 18 will not. 3 and 12 would not. 4 and 9 could. Negative 4, negative 9 could get me to negative 13. So let's go with that guy. Let's use 4 and 9. Okay? Since I have an x to the 4th, what's going to happen, it's the same thing as when I have an x squared. I'm going to make 2 sets of parentheses. The square root of this will go in the front. Okay? Because there's no number to worry about. I have a positive in the back, so that means I'm going to follow this sign, so both of them will be negative. And we said that 4 and 9 would work, so I'm going to have negative 4 and negative 9, all equal to 0. Let me erase a little bit of this so it's easier to see. Okay? Now, can x squared minus 4 be factored any further? X squared is a perfect square, 4 is a perfect square, and I have a negative, so it would be the difference of 2 squares. So I have a positive, I have a negative, x goes in the front, the square root of 4 is 2. How about x squared minus 9? Well, x squared is a perfect square, 9 is a perfect square. I do have a subtraction, so I'll have x and x. I'll have a positive and a negative. The square root of 9 is 3. So now I have x plus 2, x minus 2, x plus 3, x minus 3. Can any of those be factored any further? No, they cannot. Are any of those happening more than one time? No, they're not. But what I will do then is just set them each equal to 0. I'm going to subtract 2. So x equals negative 2. What is the multiplicity? It's just going to be 1. I'm going to add 2. So x is equal to positive 2. So again, multiplicity of 1. If I subtract 3, I would have a multiplicity of 1. and if I add 3, I will have a multiplicity of 1. Here's another thing that just popped in my head. What you can do to double check that your multiplicities are right is I have 1 plus 1 plus 1 plus 1. That, if I add all those multiplicities up, 4 should equal my largest degree in my problem. That means I had 4 answers. We've talked about in the past that my highest degree, or the degree of my polynomial, will actually tell me how many answers will be in my, or how many answers there are to that problem. Okay? So let's move on to number 6. I want to set it equal to 0, so I'd have x to the 4th plus 10x squared plus 24 is equal to 0. X to the 4th is a perfect square, which means that I could factor this normally. So I'm going to go ahead and check out 24, see if anything can add to 10. I'd have 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Well, 1 and 24, there's no combination of those that would get me to 10. 2 and 12, I could possibly, but notice that it's going to be positive, positive. So when I set my 2 sets of parentheses up, both my signs would be positive. So 2 plus 12 would never get me to 10. 3 plus 8 would get me to 11. 4 plus 6 would work. So if I use 4 and 6, I can put those at either spot. The factors of x to the 4th, it would be x squared and x squared. Okay? So I have x squared plus 4 and x squared plus 6. Can I factor either of those further? X squared is a perfect square, 4 is a perfect square, but again I have an addition, so no, I cannot. 6 is not even a perfect square, so that should tell you right away that I do not have the difference of 2 squareds. So I'm going to use x squared plus 4 is equal to 0, and x squared plus 6 is equal to 0. Now notice that the squared is not outside of a set of parentheses, which means that I do not have x plus 4 twice. Okay? And what you're going to notice here when I solve for x is here I have to take the square root. So x would equal plus or minus, square root of 4 is 2. Anytime there's a negative under the square root, I have an I. I have 2 different answers there. I have a positive answer and a negative answer. So this would be x equals 2i, x equals negative 2i. So both of their multiplicities are just going to be 1. Okay? Same thing's going to happen with this x squared plus 6. If I subtract 6 from both sides, x squared would equal negative 6. The square root of negative 6, x, would equal. I cannot take the square root of 6 and I can't break it down any further. So it's going to be don't ever forget about that plus or minus. I was trying to drill it in your heads before when we were talking about things like this. So plus or minus I root 6, which means I have x equals positive I root 6 and x equals negative I root 6. So I'd have the multiplicity of 1 and a multiplicity of 1. Again, 1 plus 1 plus 1. 1 plus 1 plus 1 plus 1 does equal my 4, so my multiplicities are good. And that is the end of our lesson. So just remember, when I'm looking for a multiplicity, the simplest way to think about it is how many times is that number going to be an answer to my problem. Okay? I've shown you a couple different ways to know if it's going to be a multiplicity of more than 1. If none of those exist, it's just going to be a multiplicity of 1. Don't forget about factoring. If you're still struggling with factoring, make sure you come in and get extra help, please. We really got to get this factoring down. It's not going to go away, guys. All right? Well, thank you very much for watching this video. If you have any questions, bring them in to me tomorrow, and have a great day.